We're here to solve this Arrow Sudoku by Rajesh Kumar called Question Marks, and it's a pretty interesting puzzle. I think it actually tested with a pretty wide solving range of times. It's not necessarily difficult in any spot, but it's got a fairly narrow solving path. Things to notice at the start, besides just the theme of these question mark shapes in left and right, is that we have no 9s in the grid, but we have a lot of the other large digits in the grid, and this sets up a whole set of different kinds of thinking, but having 5 8s, having 4 7s, and having 4 6s are all good places for both Sudoku reasons and arrow reasons to look at different cells. We'll see examples like we've got an arrow that takes 3 sum in the same region, so this is an arrow that will always be 6, 7, 8, or 9. In this case, like it sees 6, 7, and 8, so this has to be a 9. Over here is something parallel to that observation, but this one doesn't have a 7 eliminated from the start, it just has the 6 and 8 eliminated from the start. So one way to think is at the level of the arrows, but for sure where we've got 5 8s, we should look at the 8s just from Sudoku reasons. That 8 is forced, this 8, giving this 8 by Sudoku, this 8 by Sudoku. I've got 2 7s on the right side here, forcing a 7 note in this space, and 2 7s on the left, forcing a 7 note in this arrow. That's interesting, and given the one over here, this has to have at least a 2, and it can only have as large as a 2, because that's the max sum of 9. So this gets put in the grid. The 9s I've labeled to now actually force a 9 in one of these cells. This 2 may eventually play some role because it's now limiting its values across this space, so we'll keep this in mind. The main thing that I'm seeing, though, having done this, is I should actually look at the other middle-ish to large value, which is 6. It now is forced to be a note down here. Got 2 6s in these columns, so I got a 6 that's got to play out across these. Actually, that 6 to there forces a 6 here and a 6 note here. And the last way to look is that I've got 2 6s in the rightmost columns. That means the 6 is along this arrow. Again, I can't take a 1, so sum of 7 is bad. 8 is in the grid. This has to sum up all the way to 9. Forces a 3 6 here. That puts a 3 note down in this space. That 9 is, I guess, still consistent with what we had over there, and it's putting a 9 in one of these two cells and a 9 in one of these two cells. Here's where one thing solvers may choose to do is look back at one of these places we found this node and say, well, 6, can that go along a 9? And the answer is yes, it's with 1 and 2, and while the 2 down below would eliminate the cell, you can put a 2 up here and just be fine. Here's a place, though, where solvers' intuition about how do you make things work on large sums may just not be as strong as it needs to be to make these steps super fast. And that's because 9 actually has 3 options for it, and you may not know it only has 3 options, but there's some fun traits about those options to talk through. Way to build out those options is start on the low end, so 1 with 2 gives a 6. If I move up that middle option, 1 with 3 forces 5. 1 4 4 is no longer good, so the 1 is out. And 2 3 4 is the last triple that works in this way to have 3 distinct numbers that add up to 9. Now, across those, 2 have 1s, the top 2 here, 2 have 2s, and 2 have 3s. And so a thing to sort of note about this is when you actually have one of the smallest values, either a 1, 2, or 3 in such a situation, you've got a lot of constraints on a sum of 9. You don't have constraints like if this were a value like 8, like you should be able to see, well, this is exactly 1, 2, 5. Like it shouldn't take time to do that because 1, 3, 4, 1, 2, 5, you're eliminating one of the spaces. So anyway, the takeaway for here is this has to be 1, 2, 6. This being a 6 versus 1, 2 versus 1, 2, but again, 2 is down below. So these get canceled. 1 comes up to here. 2 is forced over here, but it can't be in that circle. So puts this in. We've now finished most of this column. And the last places for a 6 are actually in these two cells. So that 1 is being pushed out by a pair. Has to come up here. Puts a 1 over here. The two 6s now intersect with this note. So 6 is canceled, has to go down. 3 comes up. And so this looks like another good place to then sort of shift our thinking. And this may be where, again, like the logic flows can go together. Like these arrows can go together. But we're seeing that 9 has to be 2, 6, 1 right away. It's a master class, maybe before I introduce that, to recognize this cell, this arrow, can't be a 9. And so let's sort of go through again why that is. So here's the sum. It's in a cage with a 3. So 2 of the 3 options for this 9 should naturally be removed. And we may not remember it instantly. Well, what's the remaining value that doesn't use a 3? It's 1, 2, and 6. And there's a 6 in this cell too. So these both eliminate and say the only thing that works for the cell is 1 plus 2 plus 4, which is 7. Or if there were an 8, 1 plus 2 plus 5. So again, a case where knowing more than you should can sometimes get you some faster progress. But I think figuring out exactly these two arrows is one of the sticking points for many solvers. And until you do it, you can't get around the grid so efficiently. This 2 coming across and not in the cell means there's a 2 across these arrows. And we actually also have that there's a 1, 2, 4 here. So this is pretty nice, and eliminating this 2 and this 1 actually shows us that there is a 1 pair here, which comes down here and forces now a 1-3 pair. Removes this cell, this is the last spot for a 2. Removes this as a 2, puts in a 2 here. That forces a 2 to the top. And there might be some more we can actually do to get those exact values here. And it looks like one thing we can say is there's actually a 5 in the space, and that leaves a 4, 7 in the space. So this is 2 of 5. 5's left here, so 5 has to come up. 2 comes down. We're left with 4, 9 for these cells, a 5 up top. And this is another place to now jump to some other arrow opportunities and work through them. Yes, one thing we can do before doing that is to actually just look at some of the values we have. 2 can be in these cells, but can 2 be right here on this arrow? 2 plus 2 is 4, so no longer works with 4, and 1 or 3 don't complete out to 9, so 2 can't be on this arrow. That puts a 2 here, puts a 2 here, puts a 2 here. What can then work on this arrow? Well, 1 for 1, 1, 2, or 2, 1, 6, that doesn't work. 2, 3, 4 works. This is a 1, 4 cell. And something that you can interpret from that is actually this is a box where there aren't many cells left for a 9 to go. Actually, 9 is forced up top at this moment, puts a 9 here, puts a 4 here. It means the only way, sorry, I just had that covered, so I'll do this again. The only way this works is 2 and 3 and 4, leaving a 1 up top, puts a 1 across these cells. It means this is a 3 and puts a 5 along the last cells here. So this is 3, 5 coming up. 3 coming over here puts 3 to the left, 5 over there, puts a 5 in here, and a 5, 9. We have 1, 4 for the cell, and that's still not yet constrained, but we do need to get a 7 in the space. So looking at 7s could be key step here. And one thing to note is a 7 can't go in this cell, so we have a 7 that's got to be across those, puts in a 7 here. So this now is a 1, 4 cell. It's going to be pretty constrained across the sum, so let's see if we can figure out what that sum has to be by working across other things we know in the grid. And one of the things we can do is probably look, and we didn't do this earlier, we could have done this at some stage in the puzzle. Across this row is 3, 4, 5, and 4 doesn't work with 4 for this arrow. So earlier in the puzzle, we could have said something like, what does go along this arrow? And 1 plus 7, 2 plus 6, 3 plus 5 are the options, but based on limits in this row, this has to be 3 with 5. And we're actually so far now into this puzzle that this has to be 3 below, 5 up above. It's fairly clear. That puts in 5 with 1. This 5 means this is a 3, 4 cell here. And how is that going to work to help us? I think it's actually that we now have just the spot for the 9. Gives us this 9, this 4, this 4, this 6, this 6, and this 9. That 6 only works if this is, 4, 1, 1, like so. Puts a 4 here, a 7 here, 4, 7, 3, 3, last 4, 1, 1, 4, and we're through. So a few different themes for the logic, and I think those different themes may be where solvers would hit at least 1, if not 2 or 3 of the sticking points. The one I highlight a lot in this grid was how these 2 large sums worked, and particularly just some more thinking to keep in the back of your head about how the 3 different sums that get up to 9 work, including that they have either 2 if the digit 1, 2 if the digit 2, 2 if the digit 3. And so if any of those values 1, 2, or 3 are already in the box, you can do a lot to eliminate down to just one option. We didn't talk as much about it, but these arrows are similarly limited, like 1, 7, 2, 6, 3, 5, and given this clue pattern that had a lot of 6s and 7s in our digits at the start, a lot of these arrows were sort of primed for progress, maybe not all of them. Like this arrow is sneaky. You'll get to it can be a 4 or a 9, but you still can't actually rule out 2, 1, 1 until pretty late into the puzzle. So curious kind of Arrow Sudoku, but a really interesting theme, and the given numbers set up a pretty curious and interesting solve. So thanks, Rajesh, for the puzzle. Hopefully you got something from watching this video, and we'll see you again soon.